rotary phones. You know what these are, right? The interesting thing about these is principally there's only 2 wires that connect this to everything else. These 2 wires get connected together within the phone to make a loop that actually goes off to another phone. On this loop between the 2 wires is the microphone, the speaker, and a means of telling whatever is in between where to go and who to call. But how does it do all of this with just 2 wires? Well, with the microphone and speaker it's quite easy. They're both wired into these 2 lines. So if you talk, the signals pass through the wires in the microphone, and if the other person talks, well, it comes out of there as well. And also because of this, when you talk in here, you'll hear yourself come out of here as well. And it'll be the same case on the other phone. But where it gets quite interesting is the rotary dial in the middle. What the rotary dial does is it connects the 2 wires that are going into the phone, and it quickly turns it on and off, sending out pulses. If you dial a 1 on the rotary dial, it will quickly disconnect the line once. If you dial a 6 on the line, it will quickly disconnect the line 6 times. If you dial a 0, it will quickly do it 10 times. It does this using a switch on the back of the rotary dial. It's got this thing here, which is a governor, which actually governs the speed at which the rotary dial spins, which sets the speed at which this switch turns on and off. Each single on and off in here ideally is about 100 milliseconds. So if you type in a 0, that's 1000 milliseconds. So it basically takes a second ideally to return back to 0. Within this 100 milliseconds, there's a 66.6 milliseconds where the switch is open and a 33.3 milliseconds where the switch is closed. These quick on and off pulses then travel through the phone line over to the bit in between this and the other phone. And that is the telephone exchange. In the telephone exchange, there would have been a bunch of these sort of things. Ooh. This thing right here is a 2-motion selector switch. I've spoke about them in other videos. There's some links below if you want to find out more. There would have been thousands of these, and when you pick up a phone, one of these would get assigned to your phone. The phone would engage the selector. It's not working. It's not plugged in. The phone would have engaged the selector. And the selector has tiny little wipers which are down here, which would carry the signal, and that would carry everything from the microphone, the speaker and the rotary dial over to the next destination, which might be another one of these or the actual phone that you're trying to call. But this thing also listens to the ons and the offs that are coming from this phone. If you hang it up for longer than 100 milliseconds or so, it will just hang itself up. However, if you turn the line on and off really quickly by using the rotary dial or the hang up on top of the phone, it would start doing something a little bit different. And this is how you were able to dial a number and it would get to the phone that you wanted instead of just all the phones in, I don't know, Loughborough. So first, let's pick up the phone. You'll notice some of these relays. You'll notice that this one, and a couple of others have engaged. Well, after that, it's basically a game of timing. Some of these relays are quicker to act than others. We're primarily going to focus on this relay, which is the A relay, and this relay right here, which is the B relay. When the A relay turns on, it turns on this B relay. But when I let this off, you'll notice that there is a slight delay of this relay popping back off again. Did you see that? It's quite slow. You'll see there's about a 300-400 millisecond lag before this one actually lifts up. This gives the switch the ability to stay on when you pick up the phone and also turn it on and off really quickly when you're dialing. You'll notice this when I pick up the phone, both of them go down. However, when I dial a number, this one flaps around like crazy and this one doesn't do anything. However, when I disconnect the line for any longer, both of them will turn off. Did you see that? So this relay is a lot quicker acting than this relay, which means this one is going to ignore the 100 millisecond pulses because it's far too slow, and this one is going to tell the switch what to do because it's a lot quicker. And as you can tell, it actually works pretty damn well. This is primarily down to the wire coming from the phone going to this being relatively short. But what happens when that wire gets a lot longer? Well, because of the added capacitance of the wire just getting longer and longer for miles and miles, that really quick set of pulses from the dial is going to start getting softer and softer and less effective at doing its job. And as it gets longer and longer, it's more important that this is quite an accurate thing that sticks to the 100 milliseconds. Because if this was too quick or too slow, it would start causing mistakes over long distances. Well, somewhere down that line between the phone and the switches that are trying to direct it to go to different phones, you could put something in that line to regenerate that pulse to make it all nice and sharp again. You could, for instance, use another relay to regenerate it. You could get the phone to trigger the relay, and then the relay's output will be a lot sharper, and then that'll carry on down the line. However, that only solves half of the problem. Like I said, ideally the rotary dials will be turning off for 66.6 milliseconds and turning on for 33.3 milliseconds. And if they're a little bit fast or a little bit slow, the problems may amplify as the wires get longer. So if, for instance, the speed of this dial is a little bit wrong, well, that isn't going to be rectified by putting a relay in the middle of the line, because it's still going to be the wrong speed when it gets regenerated. And there's quite a few solutions to this problem. You can read Telephony Volume 2 by Atkins. That's a really good book that touches on all of them. This is basically just me reading that going, ooh, I'm making a video. Number one, every few months you could get engineers to go around to every single house with a phone and calibrate these by adjusting the governors on the back. That would mean every single rotary dial would be nice and calibrated and working perfectly all the time. However, not everybody was going to be making long distance or international calls all the time. So this could have been seen as quite a time-consuming and expensive solution to the problem. So remember, this was pre-computer, so you couldn't just plug it into a Windows 95 computer and just say, do this, do that, bish, bosh, bash. So there were other solutions that needed to be thought about. And when you think about the problem, it actually gets quite complicated. In order to listen to the pulses coming from a phone and then regenerate it in the right speed, that sort of requires memory in a way, because you can't do it at the same time. You'd need to listen to this and then send it out just afterwards in the right time. And at the same time, assume that the person dialing is just going to be dialing like normal. So there'll be no real time between there to kind of sit, stop, do it, and then go and carry on. So there's a number of things you need to do. You need to listen to the dial, remember what is being dialed, and then dial it again. You could make a relatively complicated circuit that basically uses relays as memory, so on and off, and then uniselectors that would drive between the different memory banks and then send it and read it. But the problem with that is you're looking at around 50 relays and a couple of uniselectors. It's going to get quite big quite quickly. You could also use uniselectors as memory buffers. These would flick through and remember the numbers, and there'll be a few of them in the line just remembering different numbers. After that, the memorized numbers could go through something like this. Oh, this thing. This is an impulse generator. What it is a motor that is then connected via a clutch that you can fine tune to make this spin at exactly 100 milliseconds. I haven't turned this on before. Let's see if it works. Oh, it works. Oh, that's amazing. So there's a bunch of switches here that touch these cams that basically turn on and off at the specified time, which is break for 66.6 seconds and make for 33.3 seconds. This would have basically gone through a bunch of these complicated regenerator circuits using relays and uniselectors and stuff, and would have dialed the regenerated pulses at the correct speeds to make sure they actually got to its destination, making the correct call. You'll notice that there's actually two different speed standards here as well. Let's give it a go. Let's give it a go, shall we? Oh. It works! This impulse generator obviously exists, so that method must have been used, and this was also used for a number of other things, but damn, that's cool. However, there is another way, and it's absolutely ingenious. It's this thing right here. Ooh! It is the Electromechanical Regenerator. Look at that. It's like some kind of thing that you dig out of the floor from 3,000-year-old alien spaceship or something. This relatively small item basically solves the problem all in one, and it can fit in your pocket. And it doubles up as a wonderful handbag. What it is basically an electromechanical memory buffer with about 40 bits of memory inside of it. What the fudge? There's no semiconductors, no weird electronics, just 3 electromagnetic coils, one here, and one here. So this item basically comes in 2 halves. This side is basically a telephone dial. It's got the governor, it sort of looks like the dial, except it is robotic. On the inside here is a programming arm that spins around. If you watch this, I'm just going to try and move it around. You can see there's a little black arm coming into shot. When I release my finger off this coil at the bottom right here, what's going to happen is that little arm pushes a pin over to the other side. Watch that. Oh, did you see that then? What happens then is you push this coil releases the dial, and this dial spins to that point. Watch, wait for it, I'm trying to make you see. And then it'll stop. I've wound that up quite a bit. But the great thing is we can program in a couple of bits into this memory buffer. So there's basically about 40 or so of these pins, and that is the memory buffer. So we'll flick over, we'll dial, put in a couple of them, push a couple of them in. And now if I release it using this coil up at the top, this one right here, the rotary dial on this side is gonna follow the pins through. Right, so push them back in. So when it's read the information, before it can get to the next step, it has to delete that piece of information. So it is destructive memory, because in order to read it, it's got to be destroyed. The other ingenious thing about this is as the programming arm spins around, it actually winds up the rotary dial. So it never needs winding up. So when it spins around, it recharges the spring that causes this to automatically move. Here we go. Pushing them in, pushing them through. And then when they end up reaching the same pin, there is a switch on this side which tells you that it's done. As you can see, when I was controlling this, it's a little bit involved to actually get it going and doing its thing. You can't just put power on it and expect it to do something. However, the other day I went to go and visit somebody called New Sandals, and they had already built a demonstration device. New Sandals was kind enough to share the schematic with me, and they said I could share it on this video as well. So here it is. This is what we're going to use to make it work. As you can see, I've already drawn on it because I have actually already built this. I wasn't expecting it to work, so I didn't do the video, but then lo and behold, it started working. Each of these little boxes right here are relays. So we've got one relay here, we've got a relay there, relay there, relay there, relay there, relay there, relay there. You'll notice that there are slightly different relays here. These ones right here are slow to release, and this one right here, because it's got a cross on it, is the opposite, is slow to engage. The M, the R and the T here are actually the coils here. This coil at the top controls this. This coil at the bottom controls the programming pin in there. And then this one controls the ratchet that will move it around and spin it around. There's also these things right here which are interrupter switches. These are the switch contacts that are around the back here. There's one here. There's one here. There is one there that tells you when it's finished its routine. And then there is also a connection to tell you when this has actually touched a pin. This is where the phone line comes in. This is where the phone line comes out. You see this right here. This is the switch. That is the dial. You'll notice that the dial switch is down there. That basically just acts like the phone again. So you'll see that flicking, and that basically just interrupts the phone line. So that is that bit right here. Oh, and that's when I went to town and I built a demonstration unit in the good old-fashioned me way, which is just stupid. There we go. Oh, this is the demonstration unit to control that electromechanical regenerator. Let's have a look at it, shall we? So I started by building this bit at the front. This is actually that schematic we just looked at. There was 1, 2, 3, 4, 5, 6, 7 relays, a couple of capacitors. There's some capacitors to stop sparks and stuff. Then I got a little bit carried away. I've added some lights, which are right here. And then further back, I've also added some buffer relays back here. And these are for talking to this box, which has a speaker, which you can guess what that is. Maybe it's a synthesizer that listens to this. Maybe it's not. Who knows? Let's find out in a mo. The first thing we need to do is get the electromechanical generator and plonk it into its socket right here. Try not to break anything. I've spent so long on this. The last thing I want to do is break it. Oh yeah, there we go. It is in. So first off, let's show you it doing its thing, shall we? I've just got to get the crocodile clips on here from the phone. Oh. So the programming and the transmitting side can both work simultaneously. So I can dial a number in on this side and program it whilst this thing is working on its own dialing out again. So we can just dial. And as you can see, it's just going to follow it. Anyway, whilst we're at it, since I've made the lights do something, we may as well have a look at the lights doing their flashy thing as well. We can also stop it from transmitting by holding the MD pin. That means we can use pretty much all of the pins and then let it send it out. This isn't what it was made for, but it does it anyway. It's pretty cool. So let's try and record it, shall we? So now we're recording in a bunch of numbers. That'll do. Now I'm going to let go and I'll let it send it out again.
How cool is that?
I've now wired it into the switch to make it do something. I haven't made it do exactly what it's supposed to do, but it does something pretty cool regardless. 0. It's got memory! It's got memory! Noises! Also, you'll notice there is this rather fetching green speaker down here. Thanks to Totem Recall for that. It's a waterproof Land Rover speaker. Absolutely amazing. It's sat on top of a box that's got a WAV trigger in it with some samples. And the WAV trigger is talking to these relays right here, which are being triggered by certain parameters that are over here. Ooh. Anyway, I hope you found this video entertaining and maybe slightly educational. If I've talked about a certain principle wrong, then please mention below, because after all, I am just a well-meaning idiot. I've been talking about this project for the past couple of weeks over on Patreon, and if you want to see other projects that I'm working on as well, then go and check it out over there. And also over there is a direct download of the song we're about to play on this, because this is a musical instrument and it has a direct output as well, so we can plug this into effects pedals and make it the shoegaze instrument of doom. Anyway, take it away.